Hello everyone, my name is Steven. A new round of the Prairie Math League has taken place, and I have volunteers to make video solutions for them. I hope you enjoyed their video.
Today I will be doing Prairie Math League number 118 by Steven. Question 4 and 6. For question 4, it is asking you, what is a squared divided by b squared? So it is asking you, what is a squared divided by b squared? That's all it's asking. But anyways, well, I'll show you the solution. So you want to draw a line in the middle of the triangle. So you'll get two special triangles. If you draw a line here, and also make this 90 degrees. So draw a line that is perpendicular to this line. You will get 30, 90, and 60. So you can know this is 30 by looking at these two angles. So you know this is 60 for sure. And since this is perpendicular, you know that this is 90. You know that all the angles add up to 180. So this must be 30. Okay. And since you also know this is 90, because this is perpendicular, so this is 90. And you know that this is 45. And you know that they add like this angle, and these two angles add up to 180, so this must be 45. Okay, so now what we can do is we assume that this number, this length here is some random number, and then we will figure out what A is and B is, and we square them both to get the ratio. Okay, so let's assume that this length is, let's just say 1 for now. So since we know this is a 30, 60, 90 triangle, we know that this is a special triangle. And if you don't know what a special triangle is it's basically a triangle where it have 30, 60, and 90 as the angles. Then you'll get some ratios between the lengths of the angles. For example, the ratio of this to this is the square root of 3 to 2. And the ratio between these two is 1 to 2. So we know that this is 2 divided by square root of 3 times bigger than this, because that is their ratio. So we can just assume that A is this number if the length here is 1. And for 45, 90 degrees triangle, the ratio is 1 to square root of 2 on the side length. So if this is 1, then B is square root of 2. So now let's square both A and B, and let's find their ratio. So A squared is 4 divided by 3. B squared is 2. So the answer is 2 divided by 3. And as you can see, the answer is A. Because this is the only two-thirds option. Okay, so now we can look at question 6. Okay, so question 6 is the one down here. Find the number of triangles if the lengths of all the integers, if the length of all the integer sides are shorter than 11 or equal to 11. So it's basically saying there is a triangle like this. They're saying there is a triangle where the longest side is 11, and they're asking you how many ways could the triangle be possible. So how many combinations? So it is safe to assume that one of them is 11 because it's saying the longest side is 11. So we can just label one side, let's say 11. And there's something you need to know about triangles. So there is a pretty intuitive theorem about triangles that's saying the two sides of a triangle, if you add them up, they have to be bigger than the third side. And this difference between two sides, so the difference between two sides have to be smaller than the other side. So for example, this, let's say this is a triangle, the difference between them, which is this one minus this one, have to be bigger than, have to be bigger than this. So how are we going to use this? Okay, so I'm just going to go over some examples that you can use this to disprove that that's a possible that kind of triangle is possible. So for example, 1, 10, 11. Actually, I don't even need to write the 11 here because you can't just assume there's an 11. This is not a triangle because I'm going to write the 11 anyways, because 1 plus 10 is equal to 11, and the theorem states that the sum of two sides have to be bigger than the other side, so that's not possible. And just to show you graphically why, because let's say this is 1, this is 10, this is 11, it will have to be a straight line. There can't be any angles because these two sides are just not long enough to meet in the middle. But so how many possible combinations are there? So let's first assume the other side is also 11 because it's saying the longest, so we can have another side with the same length. Because in this case, the longest is still 11, but you can't have 12 here. So, okay, so 11, 11, 1 would be a possible solution because it meets all the requirements, basically. And the 11, 11, 2 is also an option, and it's also possible, and up until 11, 11, 11, they're all possible. So you're gonna have at least one 11. Let's assume the second one you have is 10. As we discussed, 11, 10, 1 is not possible because 10 plus 1 does not, it's equal to 11, but it's not greater than 11. So 10, so 1 does, 10, 11, 10, 1 doesn't work. But 11, 10, 2 does work because 10 plus 2, that's greater than 11. And if you were to do like all the other checks, then that also work. For example, 10 minus 2, that is smaller than 11. So 2 definitely works. Another one that will work is 3. and it will just, you can just follow the pattern, and the 11s also work. Although we count the last one twice here, because 11, 10, 11 is just 11, 11, 10. But let's just ignore that for now. We will definitely come back to solve this problem later. So let's pretend we don't know about this problem for now. But anyways, so this is 2 to 11. So maybe you already know like what's going on here. So 1 doesn't work because 9 plus 1 is smaller than 11 and it needs to be bigger than 11. 2 doesn't work either. So you're left with 3 to 11. So this pattern will keep going. 11, if you have an angle aside, I don't know, 11, 1, then 1 won't work, 2 won't work, and you'll need to get to 11 for it to work. So basically, you'll have a pattern where it's just like the number of ways that you can have a triangle is just decreasing. So in this case, you have 11 ways because you have 1 to 11. That's 11 ways. That's 11 numbers that will all work. And here you have 10 ways, 9 ways, and then 8, and all the way to 1. So assuming you can like count them twice, for example, assuming that like 11, 10, 1 is 11, 10, 2 is the same thing as 11, 2, 10, something like that. Assuming that is true, even though it is not. Like even like just assuming like these are 2 separate cases, then let's see how many numbers of ways that we can get for the triangle. So adding from 1 to 11, there's a quick way of doing that. You just add the first and the last to get 12 and divide that by 2. So now you got your average, which is 6. And since there's 11 terms, since this is the first term and this is the second term, since there's 11 numbers here and their average is 6, you can just multiply that by 11 and then you'll get your sum. However, we will have to like subtract all the ones that we counted twice from this 66. So we get like actually the different possible ways. Okay, and okay, so you have to be careful here. You can't just divide 66 by 2 because many people is thinking this way. So they're thinking that, for example, 11, 5, 10 is the same as 11, 10, 5. So every time I'm counting them twice. So every possible scenario is counted twice. Therefore, I need to divide this by 2, so I get the total scenario. But that's not what you're supposed to do here, because there's one scenario that you won't count twice. And I will make an example. 11, 11, 11 is counted once, as it should be. Because in the row 11, that's the only time it will show up. So the problem about like overcounting, that's like the term for counting something more than one time, is that if you have 10, like this is the row of 10, like 11, 10 point something, you will count 10, 5, Oh wait, you will count 10, let's say 10, 5 once here, and then on the row where you have 11, 5, something, 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 you will count the 10, 5 combination again. So the only time you're not overcounting is when you have two of the same number. So they're in the same row, so you're only counting them once. So these are numbers such as 11, 11, 11, 11, 10, 10, all the way until 11, 6, 6, because 11, 5, 5 is never counted, because 5 plus 5 is smaller than 11, and it needs to be greater than 11. So 6 of them. So out of the 66 numbers, 6 of them are counted once as it should be, and 60 of them are counted twice. So we can't just add these two numbers up. We should add this number and half of this number, since they're counted twice. So there's only actually 30 ways out of the 60 numbers, 60 combinations that we counted. There's only 30 ways. And these 6 ways, we counted them as they should have been. So it's actually just 30 plus 6, which is equal to 36. And the answer for that is B. So if so B here. This is the right answer. It says 36 here. But anyways, yeah, that's the end of the video. And also, if you want to see me do these questions live, you can join my Zoom meeting at Wednesday. I know this is a self plug, but yeah. Anyways, yeah, I'll see you next time.